Section 1.6 is talking about one-sided limits. So we're going to investigate what these are all about. Well, in any graph, you kind of have numbers all over the place. You have x values on the left and on the right, and one-sided limits are what happens when we approach from one direction or the other. So let me give you an example image-wise, and then we'll discuss how to do this analytically. Well, if we have a regular graph here, a function can kind of go through the graph at different places. Well, if you notice, there's a left side of 0 and a right side of 0. So, we could say, like, the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right. Now, you notice the difference is that the left is a little minus sign over the 0. From the right, it's a little plus sign. So it basically means it's approaching from bigger than 0 and approaching from less than 0. So on the left side, it's what number am I going to as x gets closer to 0? And what number am I going to as x goes down from 0? Those are what one-sided limits are all about. So let's see what this looks like analytically. So I'm going to propose a function, okay, that is f of x equals, and this is going to be x squared when x is less than 0, and negative x squared when x is greater than 0. So notice that I'm not allowing x to be 0 here. So it can be bigger than 0 or less than 0, that's it. So what does this function look like? Well, before 0 it behaves like x squared. Well, x squared is kind of a parabola, and we've got an open part there. Then after 0, it behaves like negative x squared. So it's kind of like this. So it kind of looks like a cubic function, although it's not. But notice that there's nothing at 0. It's just an open hole. Right? It's just a hole. So what could we say about this? Now, first thing we could say is that the limit as x approaches 0 from the left of f of x, this is what does our function look like it's going to before it's 0. So we're looking at this part here. So it looks like we're going to 0. Right? That's good. Perfect. Now what's happening when we've got our limit as x approaches 0 from the positive side of 0? Well, if we look at this section here, it looks like, again, we're still approaching 0. So from the left side and the right side, it both says that our limit is going to be 0. Now, what this means is that our overall limit, the double-sided limit, and so, this implies that the limit as x approaches 0 of f of x equals 0 overall. Now, it's because the left and the right side agree. Now, a lot of people get tripped up on the fact that, well, you can't plug 0 into this function. It doesn't equal anything. Well, limits have everything to do with what does a function look like it's going to do. It doesn't have to actually do that thing. It doesn't actually have to exist at a place. But as long as it agrees on both the left and the right to what it's supposed to do, then the overall limit is going to exist. Say, it does not matter that the point doesn't exist, right? 0 is not a part of this domain. Yet, we can still comment on what the limit of the function is. Now, let's look at a different example here. I'm going to slightly alter this. I'm going to say f of x equals x squared when x is less than or equal to 0, and I'm going to say negative x squared plus 1 when x is greater than 0. Okay, so let's graph this and show you how this is a little different than the other one. Well, I'm x squared when less than negative or equal to 0. So that actually has a filled in dot. So 0 is now a part of our domain. Now, I'm negative x squared plus 1 when x is greater than 0. So the difference here now is that I added this 1, and now the negative x squared plus 1, right, it's been moved up a little bit, and this is when x is greater than 0, when x is positive. So we can comment on what's going on here, okay? So the limit as x approaches 0 from the negative numbers, or from below 0, we're looking at this. Well, if we look, it seems to be approaching 0, just like before. It has nothing to do with the fact that I'm allowed to be 0 here, right? It has nothing to do with that it is 0. It has everything to do with the fact that it looks like it's going to 0. It's consistent. So let's look at, from the right side, the limit as x approaches 0 from the positive numbers. Well, that looks like it's not going to 0 this time, right? It looks like it's going towards 1. Okay, so it's different this time, right? These two-sided limits aren't agreeing. And what that means is that the limit as x approaches 0 of f of x does not exist. Because they do not agree, right? It's not predictable left to right at this place. And then everywhere else, though, the limit exists. Everywhere else we could find it. It's just at this part right here when x is 0 that it's not predictable. I mean, if you're on the if you think about it, if you're on the left side, everything's making sense. But then all of a sudden it just jumps. And then it starts making sense again. But just right at that place it doesn't make sense, and that's what limits are all about. So for the most part, limits are always going to exist. Only at places where, you know, the wacky stuff is happening, that's what you want to think about. So big key here is that, you know, for a limit to exist, it has to agree to left and right. And also, a couple of things. So notes. One-sided limits always exist. So they could be, you know, 1, 2, they could be infinity, negative infinity. Right, they always are going to approach some number. It's whatever the function looks like it's going to at that place. So we're always going to have that pretty much happen. Unless, for instance, we only have points. Unless only points exist, the limits are going to exist. Okay, I mean, I guess using the term always isn't great, but virtually for this class, we're always going to have that happen. And then double-sided limits, or limits, don't exist at infinity or negative infinity. They do not exist. Okay, so I know I'm saying that again. So like if two one-sided limits approached infinity or negative infinity where they agreed, the regular limit wouldn't exist because they're not regular numbers. But that's pretty much the rules for these. So really what we're looking at is making sure we pay attention to whatever the direction is. Is it below a number? Is it above a number? And then we go from there.